Good morning and good afternoon. Welcome to RCAP, Lessons from the Field, Operator and Trench Safety. Your presenters today will be Curt Bigge and Chad Thompson, both from the Midwest Assistance Program. RCAP is the Rural Community Assistance Partnership. It's a national network of nonprofit partners with over 300 technical assistance providers located across the country. RCAP works to improve the quality of life in rural America, starting at the tap. RCAP serves more than 3.4 million rural and tribal residents and over 2,000 communities in all 50 states, Puerto Rico, and the U.S. Virgin Islands. MAP, the Midwest Assistance Program, and RCAP focus on providing assistance, training, and capacity building. Our sponsor today is the EPA. They have funded this training. Our disclaimer, content and opinions expressed today are not necessarily reflective of the views or policies of the US EPA. Some webinar logistics. Certificates are emailed out, but those folks looking to get CEUs or contact hours will need to request that from their primacy agency. We can offer no guarantees that all primacy agencies will accept this training as credit. If there are questions from your primacy on the training, they can contact us and we will try to help answer their questions. Questions about the training that you might have today or the presentation can be added to the chat box or a question box, and we'll have time to address those questions at the end. Slides can be downloaded. I believe Coy has them in your handouts, and they'll be made available to all attendees today. At the end of this presentation, we will have a survey. Please let us know if there's future topics you would like to see presented, and if you could fill out that survey at the end, we would appreciate it. We have a couple poll questions that we'd like to take before we get started with our presenters. The first poll question today is how many people are attending at your location? Coy, if you could launch that poll, please. And Coy, if you are talking to us, we could not hear you.
No, I haven't said anything yet, but I'm not sure if you're able to see the results of the poll, but I'll read them off for everyone. It looks like we have 70% of just a single person attending at their location, 27% of 2 to 4 people attending at the location, and then 3% of 5 to 10 people attending at their location.
Okay, thank you for that. Our second poll question today is, what is your organization type? Are you a small utility, a large utility representing a regulatory agency? Are you a technical assistance provider or other? If you could take a second and answer this poll question for us, please. All right.
It looks like a majority of people attending are part of a small utility at 40%. Second up are people who are a technical assistance provider with 33%. And then you have the rest coming in at large utility, regulatory agency, and other.
Oh, fantastic. We have one additional poll question. How many years of experience do you or your room average have for those folks that might have multiple people attending, watching this presentation together? You can take the average. For those viewing this presentation solo, if you could just pick your years of experience, please.
So it looks like the average years of experience are actually on both sides of the spectrum. So more than 70% have more than 10 years of experience, and then 21% have 0 to 2 years of experience, with the remainder being 3 to 5 years experience. So we have a lot of experienced people here on the webinar today, which is good to see.
Yeah, fantastic. Okay, we only have 60 minutes today, so we want to get started. I'll turn this over to Curt Bigge with the Midwest Assistance Program. Welcome, Curt.
Good morning and good afternoon, everyone. Again, my name is Curt Bigge. I would like to take just a couple of moments to introduce myself. Trying to get my web camera to come on here for just a few moments. I was born and raised in Stockton, Kansas. I did move away in 1989, but in 2016, my family and I moved back to Stockton to be closer to my folks. About our family, our free time is entirely devoted to kids and kids activities, and most of those activities have something to do with horses and dogs. We do spend a lot of time outside. We try to go camping and fishing whenever we can. About me personally, I have been very fortunate that I have absolutely loved every job I've ever had. I started out working as a paramedic for close to 20 years in Greater Kansas City. And an opportunity came up for me to take a position as a health officer in an industrial setting. That eventually opened the door to me becoming a health, safety, and environment coordinator for a large offshore energy exploration company. And working with them, I had the benefit, the privilege to travel all over the world. They turned me into an expert in conducting risk assessments and developing emergency response plans and safety plans for projects. I've worked on projects as small as $10,000, and the biggest I worked on was $36 million. And today, I would like to leverage some of my experience and introduce you to a system that would make your job sites a little safer. So for over 100 years, we've known how dangerous working in the utility sector actually is. For the last several decades, we have known what we can do, what we should do, and what we must do to make the job site safer. So then I ask you, why is it that every few days we see a new headline? We see a new leading news story where people working in the utility site have been injured, crippled, or even killed. I'll take that question one step farther and ask, why is it when we have an incident? And if you notice, I call it an incident. I won't call it an accident. An accident means that every possible preventive step was taken to prevent the event. Most of these are not accidents. When we have an incident, why is everyone so surprised? Why is everyone so shocked? Here you'll see a headline where the county officials are quickly getting in front of the press to try to shift blame. I would like to draw your attention to this slide. Please take a couple of seconds and look it over. 5 employees were charged with manslaughter. The site foreman, the site supervisor, the site manager, and even 2 workers who were buried in the trench but survived have all been charged. We're all familiar with companies receiving $60, $70, $80, even up to $200,000 fines for events that occurred on the job site. But this is a new trend that we're seeing more and more often. This is based off of the concept that everyone is responsible, someone is accountable. This originated in Canada's version of OSHA, and it's slowly working its way through our legal system. In the past 4 years, we have seen employers and coworkers get jail time for injuries and deaths on work sites. In short, if someone dies on a job site and other people on the job site knew better, they can be held criminally and civilly responsible. We've got to do something to protect our coworkers, our family members, and our friends. So today I'd like to introduce you to the life-saving rules. The life-saving rules can be a very effective framework to any safety plan. The life-saving rules are a proven system that saves lives and prevents injuries, which in the long run saves time and money. Today I only have enough time to give you a brief introduction to this process. I wish I had several hours to go over with you in detail. And if this process is something you're interested in, I would welcome the opportunity to discuss it to you in greater detail at some point. The life-saving rules originated in the offshore oil industry. This program was found to be so successful that it was made mandatory throughout the entire offshore industry, and now it is slowly spreading into utility construction companies. It has started to make its appearance in various insurance policies, especially in communities that have experienced tragedies at the worksite. It is my hope that we can influence organizations to include the life-saving rules in their safety plans, and for the organizations that don't have safety plans, let's help them see the value of taking that step and developing a safety program. Okay, let's get into the life-saving rules individually. Bypassing safety controls. So safety controls are frequently bypassed purely out of convenience. Smoke alarms are disabled because the work activities that we're doing are kicking up dust. Blower fans are shut off because they're too noisy, they're too difficult to talk over. Safety switches are disabled just because they're inconvenient. We must teach our staff that they are required to obtain authorization before overriding or disabling a safety control. They must obtain authorization before deviating from a procedure, and they cannot cross a safety barrier without approval. I'm sure all of us are familiar with tragedies that have occurred in confined spaces. We must develop and enforce a confined space policy. Confirm that the space is energy free. Confirm the atmosphere is safe to breathe and being continuously monitored. Insist that breathing apparatus is on site and that people know how to use it. During a confined space entry, an attendant who has no other task other than to be the safety lookout must be present. Confirm a rescue plan is in place and do not enter until a subject matter expert has given their authorization. For most of us, driving to and from work and driving while at work will be the most dangerous thing we do on any given day. Develop a driving policy. Make sure your people wear seat belts. They follow the speed limit. Reward them for slowing down when road conditions call for it. Do not allow them to use phones or other distracting devices while they're driving. Are the vehicles in good condition? And are our employees well rested? Are they healthy enough to be driving? Energy isolation. As an industry, why do we continue to allow our staff to work on energized objects? We should be teaching them to identify all potential energy sources, develop a policy that mandates all energy sources are isolated, locked, and tagged, teach our staff to test for residual or stored energy. Hot work is a process that develops enough heat to start a fire. Prior to doing any hot work, our staff should be trained to identify any ignition source and remove or isolate any flammable material. Do not start hot work without authorization from a subject matter expert. When working in hazardous areas, do not start work until the atmosphere has been tested, and we continue to monitor the atmosphere while the work is being done. Line of fire. We got to develop the policies to where we teach people to keep themselves and others out of the line of fire. Don't let them position themselves to where they can get hit by traffic, hit by a broken chain or a broken cable, or put yourself in a position where something can be dropped on you. Let's teach our people to establish barriers and exclusion zones. Let's limit our loose tools that could become potential dropped objects. When it becomes necessary to use equipment to move something on our job site, let's take a couple of moments and develop a lift plan. Let's get control of the area. Do we know how heavy the object is? Is our equipment capable of lifting it? Have we inspected our slings, the rigging? Are they in good order? Are they fit for purpose? Is the equipment operator qualified? Establish and obey barriers, exclusion zones, and never allow someone to walk under a suspended load. Work authorization process. So this is where we develop a program of work permits. These would be used in our operations with increased hazards. They can also be used when we have newer employees, employees with less experience. Teach our staff to check if the permit is required. Confirm that our staff is qualified and authorized to do the work. This permit can be used as a safety checklist to confirm that hazards have been controlled. Working at heights. My personal experience has shown me that this is probably the most misunderstood rule of all. Staff do not understand or appreciate the risk they put themselves in. They don't understand how dangerous a 3-foot fall actually can be. And it's not uncommon for workers to put a 12-foot lanyard on when they're only working 6 feet off the ground. Let's teach our staff how to protect themselves from falls, how to prevent dropped objects, and install and identify proper anchor points. So you might be sitting there thinking, this all sounds great, but how do we do that? Where do we start? Well, we start with little steps. It's going to take a little while, but you start by reevaluating and documenting your organization's policies, and you set up, I mumbled that up good. You start by reevaluating and documenting your organization's priorities. We set up policies and procedures that align with the life-saving rules, and we take time to evaluate hazards, review past instances, and seek the proper mitigations. Does your organization hold pre-job or pre-task toolbox talks? This is where we discuss the goals, hazards, and we give out safety reminders. Be on the lookout for dangerous mindsets. You know, the guy that says, we've always done it this way. Well, this is how I was trained. Or we're in too big of a hurry to do all that. Lastly, investigate instances where safety policies were violated. Seek the root cause of what happened. Most organizations stop the investigation when they find out who did it, but they don't find out why they did it. Hold staff accountable for their actions, and enforce a zero tolerance policy for blatant, intentional violations of the life-saving rule. One of my former managers was famous for saying he would rather fire an employee and send him home alive than to have an employee blatantly break the rules and send him home dead. So remember, everyone is responsible, someone is accountable. At the end of this presentation, you'll see Chad and I's contact information. If there's any of this that you would like more information on, again, we would welcome the opportunity to talk to you about these subjects in depth. And if you, please think over a couple of your questions you might have, because we'd be happy to discuss them at the end. Thank you very much for your attention with this, and Chad is your next presenter.
Hello, everybody, and thanks for taking your time to stop in and talk with us today, or watch us today. So a little bit about me. I grew up similar to Curt, I grew up in Eastern Montana. I left, I went to the California, San Diego area. I worked for wet utilities for almost 12 years. And then when my kids got school age, I went to work for a water district and spent 23 plus years working with the water district. In the utility maintenance section, I held positions from utility worker to crew lead up to utility maintenance supervisor when I left. So with that, I will jump in to my program here. So trench safety, things we're going to go over today are the hazards, roles, responsibility, protective system, and guidelines of trenching.
Hey, Chad, could I interrupt for just a second?
Yep.
Could you start that slideshow from your current slide? We're seeing multiple slides on your screen.
Oh, sorry.
It's that second one over from the left.
Did it change? Is that better?
And then can you swap your display settings? That's the middle drop down there.
To presenter? How's that?
There you go. Thank you. Perfect.
Is that coming through?
Yep, looks good. Thank you.
I'm not hearing Jim now.
Coy, do you want to let him know he's good?
Hello?
Yeah, you're good to go. Let's continue the presentation.
Great. Can you hear me now?
Yep, we hear you.
Okay, I can't hear anything, but
In here. So excavation hazards. Excavation has always been a dangerous industry, and as you can see here, you have a much higher likelihood than your general construction trades to be killed. I apologize for this, everybody. So here we go. From 1992 to 2001, the CDC, there was over 400 deaths in excavations, where you combine all other events in construction industry, you were less than 100. I threw this slide in. I just like the old school days compared to the modern ways of excavating. You see they just throw a little timber in on top and a lot of handwork, and it looks like they leave a plug of dirt in each little section until they get ready to lay the pipe. But a much different world than today. So what is a competent person? A competent person is someone who is capable of identifying existing and predictable hazards in their surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has the authorization to take prompt corrective measures to eliminate them. I would encourage everybody to let all staff take prompt corrective measures to eliminate any hazards or stop a site and get everybody out of the trench and discuss any safety concerns that may happen during work. So roles of a competent person: they're responsible for the overall safety of an excavation. They should be knowledgeable in soil classification. They're going to select the proper protective system. They're going to represent the employer, or one of the people representing the employer, in an OSHA visit. They're usually going to be the person who's the first person when OSHA stomps on site. They're going to ask who is the competent person on this site. They need to be there and able to answer their questions. And they need to have the authority to implement protective measures. They're identified in writing by their employer, so that has to be a designated person. You can't just make it up as they get there. They're a key piece of any safety program. They're required on site that has an excavation. So it can't be the foreman runs off to go get material or somebody who's not there. Whoever is a competent person needs to be on site and monitoring the situation. Publications and the ability to conduct the job. And it doesn't have to be a foreman or a supervisor. Anymore, many companies are training all of their staff to competent person levels. But there is going to be one who's designated and signs the paperwork and is the competent person for the site. But it's a good idea to get all your staff trained to that level and able to identify and know the hazards before they cause a problem. So with that, who wants to be the competent person? Excavation requirements. So these are some things we're going to touch on. Will be the surface encumbrance, underground installations, access, egress, exposure to vehicular traffic, exposure to falling loads, hazardous atmospheres, accumulation of water, adjacent structures, loose rocks, inspections, and fall protection. So surface encumbrances, that could be anything from a fence, a pole as you see in this picture here, a signpost. And the agency I worked for, it was before I was there, the only violation they had ever got from Cal OSHA was a tree. And they had dug a hole about 8 foot deep, about 6 foot off of a tree. And that they also need supported if you're digging out in front of that kind of situation. 811, with everybody or most of the people having over 10 years experience, I know we're all familiar with the National Call Before You Dig Center. Things to keep in mind is if you call on a Monday morning and say you want mark out, they have 48 hours to mark out, but that's not from the time of call. That is now from the next business day. So if you called the Monday morning, you wouldn't be able to dig till Thursday morning because Monday doesn't count and they would have Tuesday, Wednesday. If there is no mark out, you're still not clear to dig unless you've received a email or a phone call saying you're clear to dig from all underground utilities. So I would recommend stopping by the site on a Wednesday afternoon if that was the case, making sure you have your mark out, and if not, calling back in with your ticket number. Let them know you have no mark and you're going to have staff and equipment on site in the morning, and that typically will get them out there with whether it's overtime or not to make sure you're marked out and ready to go. Access and egress. Once you have a trench that's over 4 feet, you're required to have a ladder. Doesn't mean you need to wait for the 4 feet. And in that ladder, it has to be within 25 feet of access. So I recommend putting your ladders in every 50 feet or even a little shorter. Is always going to keep your staff within 25 feet and make sure they have a way to get out with safe travel. Vehicular traffic. Know your roads. Each area is going to be different and have different regulations, but road is going to determine your sign spacing, your cone spacing, even your PPE. If it's a certain class road, you may need a type 3 vest, which would have sleeves on the vest and more reflective material. Some areas require you to have pants with reflective material if you're working night work. So it's important you know the road you're on and what your local regulations are. Falling loads, I like this picture because they're using taglines. Taglines is a big thing. And kind of as Curt mentioned, never let anybody stay in this shield while the next load comes over. Even if you're laying pipe in a trench shield that is longer, make sure the pipe is coming into the shield in between the two pipe layers. Never swing it over somebody's head. And these big pieces of equipment you're moving, make sure you have those taglines to situate them and get them in place, and then put your staff back in the trench to put your pins in and lock it in place. Hazardous atmosphere. If you're working in or around landfills, chemical plants, wastewater plants, refineries, the gas and diesel tanks or swamps, you should test the air. But really, anytime you suspect there could be an issue, quick story here, we were doing a sewer replacement many years ago. It was about 14 to 16 feet deep in the middle of an intersection, and the guys they smelled petroleum. So we monitored the air, and it wasn't enough to set off the alarm, but what we did is we threw a 30-inch blower in there, and we just had the 30-inch blower going to make sure they didn't have to breathe those, just smell that smell of the petroleum products. So water hazards. If you're working in an area, and we all know our valves don't shut down perfect, you have to protect the employee while they're working in the trench. So if you do have to deal with the water, make sure you have your pumps in place, everything going. Ideally, you would have a shield or a trench box or something to make the work area safe, like you see in these pictures here. And do the best you can, but it has to be safe for the employees. There is times you're going to have to deal and work in some water. We all understand that, but make sure you're doing what you can to make it safe and you're not letting them be exposed to any hazards. Stability of adjacent structures. So ideally, we would never have anything built within our easements or near our lines. But if you do find you have a problem and it's next to a building, a bridge, or any of that kind of stuff, a registered professional engineer would be required to design the underpinning for those kind of structures. The competent person can make sure that all your sidewalks, your pavement, walkways are supported. And if for some reason you're doing a service lateral replacements or something and you are boring under a sidewalk and you're going to leave it that way overnight or let people use it, that needs to be supported, or if you're letting people get under there. So you need to shore that as well. Exposure to loose rock. This picture on the left is a nice V ditch. You see it's laid back. Same thing years ago, abandoned trenches like this, but it's shot rock. So when you V those ditches out, you can't get all that fine rock off the banks. What we've done is rolled chain link down that bank and pinned it on top. And we just had a couple of staff moving the chain link as we were laying pipe along through there. And it's a good way to hold that loose rock back from sliding down on anybody in the trench laying the pipe. So, inspecting of the trench. A competent person must make an inspection of the excavation at least once a day at the beginning of the shift. Additional inspections must be made or after a hazard increasing event, rain, earthquake, those kind of things. Things that must be included in the inspection is the soil type and composition, if not assumed type C, which we'll get into in here in a minute. Condition of open trenches, condition of the manufactured protective system or the shoring, the shield, the box, and you should document all your inspections. So OSHA requires a minimum of 1 inspection per shift, but the process is continuous. This is the competent person designs and constructs and maintains a safe working area. But again, I would recommend you encourage everybody to constantly monitor and observe things and give everybody the authority to stop work, everybody get out of the trench and have a meeting if there is safety concerns. Don't put that on one person's shoulder or expect one person to see everything. More eyes are always better. So here is just a generic trench inspection form. You have your location, date, inspection time, your weather conditions, temperature, crew lead, and supervisor. Then you get into your depth, your soil types, which they have solid rock, which I don't know how you're going to dig if you have a solid rock, your average soil, a fill material, which is generally what we'll find if we're repairing an existing line, loose sand. Did you test it, yes or no? If you assume it's a type C, you don't have to test, but that's each individual case. I typically prefer to just classify things as a type C. Your hazards, it's just a good checkpoint. Your saturated soils, cracks and fissures, bulging, heaving, frozen soil, superimposed loads, vibration, and a depth greater than 10 feet is just a good reminder. Think about everything you're doing. Protective measures for your shoring. Typically what you're going to be checking here is either hydraulic, trench shield, trench box, or your sloping. You have your sloping for your type C and your type B soils here. Placement of spoils, make sure it's 2 feet away, your equipment is away. Is there a backhoe at the end of the trench? Is your ladder located in a protected area? Is it within safe travel? Is it secured and tied up to something or staked in? Is it 3 feet above? And does it have a safe landing? If you suspected there was bad air, did you use a gas detector or did you issue a confined space? And then this is just saying that you inspected your shoring equipment prior to use and it is safe to enter. And any comments? Fall protection. If you're setting something up like this picture on the right that's more of a long-term excavation, you're required to have a guardrail around the system, and you should protect for fall protection at all times, but it's required for these pits or shafts, something if you're going to be boring or working on something more long-term. You can't quite see it in the picture here, but this ladder is coming up on the side. Then they'll have a chain and a platform right there where somebody can get in, and the chain should go back up once the person has entered the area. Soil classification. If you're classifying the soil, you want to take that sample and classify the soil as soon as it comes out of the trench. I believe you have an hour, but I typically try to do that as soon as the material was being pulled from the excavation. You don't want to go grab from a spoil pile that's been sitting out forever, and you don't want to go grab from that spoil pile after he's wetted it with the water truck. You want to do it with just the native soil straight out of the trench. So if a cubic foot of dirt weighs between 90 and 140 pounds, you have to think a cubic yard is roughly a half a ton. Another quick story here. When I first started at the water district, a coworker was always limping around, and I know he went to the doctor a lot. He had been there before, and come to find out, He was laying pipe in a trench not much more than knee deep, and it sloughed off. And about a year after I started, he got medically retired at roughly 40 years old and lost his job with the public sector from laying pipe in a trench just over knee deep. So don't feel like if it's shallow, nothing can happen. Soil classifications require soil definitions. The soil is based on site and environmental conditions. To classify soil, you must perform a visual and a manual test, and that's got to be done by a competent person. So the one exception to this rule with OSHA is if you consider it a type C. If you consider it type C soil, you don't have to test, and that is becoming more popular in the industry, especially with those of us already working for the public sector who are out making repairs. Typically, we're digging in pre-disturbed and saturated soils, or at least wet soils. Your different type of protective systems, you have an angle or repose, or sloping, or benching, shoring. I like this picture here. You see they're using the fin form or sheeting. That is typically what we always did if we did use shoring, and trench shield or trench boxes. Protective systems. Every employee working in an excavation over 5 feet must be protected. Again, your options to protect them is an angle of repose, shoring, or shields and boxes. So here is straight from the OSHA regulation that every employee shall be protected in cave-ins. The exceptions, number one here, the excavation is made entirely in stable rock, which again, I don't know how you're going to dig in stable rock and keep it stable. Or two, it is less than 5 feet, but here's the kicker, and the competent person provides there is no indication of a potential cave-in. We're going to get into a slide here in a couple that shows just exactly how many injuries happen in less than 5 feet. So a competent person can design a protective system for depths up to 20 feet. Greater than 20 feet, a registered professional engineer or manufactured tabulated data is required to design that system. So this is the slide I was referring to. As you can see here, we have 37% of injuries and fatalities happen in 0 to 5 feet, 26% at 6 to 10, again 26 at 10 to 15, and only 11 at the 15 to 20. My thoughts on this is, one, we don't dig between 15 and 20 that often, and typically when we do, you're going to make sure everything's right. You're typically in a shield or a box, and it's a much safer environment. And I would even venture to say many of these injuries are setting things up. As you get into those deeper depths, it gets harder to set and stack your shields and boxes. The 0 to 5 feet, you see 37% of your injuries and deaths. And again, this is just my assumption, but I would say that's many times where the competent person says it's okay to get in there and do something, and now somebody doesn't go home or goes home in a wheelchair or permanently injured. So keep that in mind when you're out there doing that work. Do you want to be the person who put that person in that trench and didn't let them go home or go home the same? So sloping, here you can see a couple of pictures of slope trenches. The one downside to sloping is you can tell they cleared timbers for this project. The amount of room you need to do the work, it's pretty wide, and it even looks like they're throwing a lot of their spoil up around the timber, which I don't know how they're going to get all that out. But that's the downside to sloping. It is nice if you're doing new construction in an open area, but it does require a big footprint. Benching is probably your pipe layer's favorite type of protection. These benches are usually 2 feet each way until the bottom, and then it's generally 3 feet. It's nice because you have the shelf to set your tools, as you can see in this picture here. The staff can get in and out of the trench really about anywhere easily and safely. The downside, again, is the amount of room it takes. And two, it takes a skilled operator. not all operators can dig and give you a nice clean bench. This to me is not the prettiest benching I've ever seen, but it is protected. So description of a trench shield. A shield is a movable box strong enough to protect the employees, but light enough to handle. And by handle, they don't mean the people in the trench. That's going to be the backhoe to drag it along and work with it as you go. Ideally, it would be 4 inches narrower than the width of the trench, so the backhoe can hook the cable to it and drag it along if you're using it in a dig and lay operation. And it's got to be rated for the depth and the type of soil that it's being used in. Manufactured tabulated data shall be on site. It should be available for OSHA, but it should also be available for your employees to make sure you're putting them in the proper safety equipment to withhold the material that you're putting them in the trench on. Here's an example of some tabulated data for aluminum shield. You can see it has a manufacturer, serial number, model, your lifting, how much lifting pressure you can put on it, then your soil types. So this is where you can see on a C60 or a type B, this trench shield is rated for 32 feet, or on a C80, it's at 18 feet. It has your soil descriptions, your placement, and the big thing is a certified engineer stamp down here on the bottom. That tells you that it's rated, but it's up to you to properly classify your soils, make sure you're selecting the proper shield that matches for the soil conditions on site. Here's an example of some non-serialized tabulated data. I know this is hard to see, but it's going to be dependent on the width of your shield. Is it stacked? It's going to break it down for different soil types. And like on this picture on the bottom right, you can see they have an end panel in the shield, which is going to make it more secure. It's a full panel. But you need to make sure you're using these within the tabulated data. All shields must stick above the ground. You can use some sloping to make it safe. If it doesn't come above the ground, this needs to be 18 inches out of the ground to the top of your shield. I'm not a big fan of the angle of repose, which is this slide here. And the reason being, if you have this sloped or using the angle of repose with your shield sticking out of this, your staff are usually standing up here on ground level for your top men who are there to help. One, they can't see in the trench to help. Two, if your staff in the shield need to come out, they come up the ladder, you have to have another ladder on that angle of repose. And it's just, I would much rather dig it vertical, stack a second shield, and have your top men be able to see, be that top set of eyes, hand them their tools and equipment back and forth in. But it is an allowable method by OSHA standards. This is just showing some of the development of the trench shields over the years. So this is a 3-sided box with the 2 spreader bars in here to lock it in. Those bars, as you can see, can be placed at different heights if you needed a window to lay your pipe through. And then they have their end panels stuffed in here behind this other panel to make it secure while you have this utility in between. The other thing, if that utility is a conduit or something that's flexible, you may have to support that. That's part of your 811 notification. You're responsible to protect all existing utilities. So if you had a wide trench, you would have to support that line while you trenched under it. This is hydraulic shores and how they work. They produce these arcs out, which is what actually supports your walls. And that's where I like to put the sheeting in behind them. It just is going to make that arc a little broader and wide spanning, and it just stops a small piece of material from falling down and on the staff. And here's your tabulated data for shoring. As you can see, again, on the type A, I've never seen a type A soil that somebody can dig in. So as I go down here to the B, you have your horizontal spacing. You see it gets smaller as your depths get larger. But this does also show that you're approved to use it at the depths over 20 feet. And then when you get into your type C soils, you see it gets even smaller. And under the sheeting on the note where it says 4 is going to tell you that sheeting is required. So on the type C60 with shoring, you could use it at 6 feet without sheeting. Again, I would recommend using sheeting if it's available. But at 5 feet or at 11 to 15 up to 25, it is sheeting required. And with that, we can go to some questions if there are some. And I apologize again, I'm not operational here for everything. But as Curt said, if you would like to talk some more on any of this, please don't hesitate to reach out to us.
Yeah, can you hear me okay, Chad?
Now I can, yeah, I don't know, I apologize about that.
Yeah, no worries. We did have one question come in, and it was how we can hear more about the life-saving rules. Is this a topic you would consider presenting in more detail in the future? And maybe that one's for Curt.
Can you hear me, Jim?
I can.
There, I was having, my screen was flashing mute, unmute, so I didn't know if it was coming through or not. Yes, that is something that I'm very interested in giving. The life-saving rules to teach the management and teach the workers are actually two different types of classes, but the introductory for the workforce is can be an 8-hour class, and what we're doing at that point is we're teaching the workers to identify all the little nuances with a job site. There's a lot of pictures involved of, here, look at these photos, tell us what you see, which life-saving rules are being violated in this photo. And that is something that that we'd be very happy to give more training on that subject.
Yeah, excellent. Would you think a webinar like this would be a good media for that? And would you want more than 60 minutes to discuss those?
Yeah, it would kind of depend on what our audience would like, but yes, it would be a little longer than an hour for just a real good introduction.
Okay, fantastic. When we fill out the evaluation at the end of this presentation, if you have some interest in that, be sure to write that down on topics that you'd like us to consider. I had a comment since the 90s. I've seen very little improvement in trench protection or even confined space entry. I think, in South Dakota, where I'm located, every year I see fatalities, trench especially fatalities. And I picked the 90s because in 1997, I was actually awarded a scholarship for water and wastewater treatment. The college I was going to, a past student had actually was one of those fatalities, and that student's parents started an endowment and scholarship in their name. And so I was awarded a scholarship based on a confined space trench fatality. And so I've always been really sensitive to that, knowing, I didn't want to be in that position. And I just see routinely, especially in South Dakota, every year we have fatalities, trench work fatalities. I had another comment too I wanted to make. I've been in the water wastewater industry for 25 years, and I've been in confined space a lot with water treatment plants, wastewater treatment plants. Every tank seems to be confined space. But I want to let you know one time, and we had permits in all of our confined space entry, and we had blowers to make sure that we were bringing clear air in. Our gas monitor went into alarm, and we were having carbon monoxide levels increase in the confined space that we were in, because the blower exhaust was located too close to the hole. We had a gas powered blower, moved a ton of air, but because it was located near the hole, that carbon monoxide dropped into the tank. Luckily, we were measuring with our 4-gas air monitor and could see those levels elevate. And when it went into alarm, and you know, in this situation, wondering where carbon monoxide, where the source was coming from, tying it back to the actual gas-powered blower. I also see sometimes folks park vehicles close to manholes or close to below ground confined spaces, and exhaust from the vehicle also can drop into those confined spaces, and ultimately the operator is the source of you know, the hazard, the atmospheric hazard, because they're either parked too close, or in this one case in the tank that I was in, the fan was providing that issue. So we tagged the gas powered blower, red tagged it, and then purchased electric blowers at the treatment plant. We had power always available, so it wasn't an issue that we had to have gas powered. It was just older equipment that was on site that we used. From that point on, because power wasn't an issue, we always used electric, so we could avoid that issue.
Well, another thing for the trench and shore is don't feel like you're on top of the trench, you're not at risk. Back in '93, I was on a site, and thankfully I was on the other end of a larger site. But we were laying 96-inch pipe. You had to pull the shields out to swing a 40-foot stick of pipe in with the cranes. And unfortunately, there was a collapse, and there was death, and another coworker buried. Those were 2 staff that were on top. The people in the trench were always inside a shield. But you had part of a cave in, those guys went down, and then more came in behind it. So it was a concrete truck driver actually who was just standing on top of the trench waiting to pour, and the foreman who ended up being buried. The foreman lived, thankfully, because he got his heart out over his face and had a piece of asphalt bridge over him, and he was in really good shape. He was a bodybuilder, or they don't think he would have made it either. But yeah, there's many hazards out there, and it's important that everybody take it serious and watch out for one another. Like I said, we all want to see everybody go home at the end of the day. So just because it's shallow or these other things, I'm sure as all these people in the audience with all the years of experience there is have stories, but there's a lot of people get hurt in small things that everybody thinks is a routine day-to-day operation. But when you start you're blind to the risk is when things happen.
Yep,
And
agreed.
Jim,
I'm sorry, I had another question come in, but go ahead, Curt.
No, well, I was just going to comment on a couple of things you said real quick, Jim. The since the 90s, our workforce is steadily getting older, and they're retiring. And because of financial considerations, small communities, not necessarily always small communities, but we haven't had time to hire somebody in, haven't had the resources to hire somebody in and have them be mentored by that individual. We wait till he retires and then they replace him. And now all of a sudden we've got someone who doesn't have anybody there to act as a mentor. And we're actually are seeing a steady rise in our events. That's why the insurance companies are starting to take attention to this. There's a couple of communities that I work with that have had fatalities in the last 5 years, and the insurance companies, the supporting them, have made them pass components of the life-saving rules, turned them into city ordinances so that they could prosecute. a little more readily. The example that you gave with carbon monoxide is a very good example. Those of you here in the Midwest, high plains, you're aware of the bad weather we had this spring, the real late, very severe freeze. There was a small town, about 250 people. The entire city maintenance team is they're all the same family name. They parked a truck about 3 manholes down, had the manhole cover opened, had the truck idling because it was below zero and they needed a warm place to go to. They all 3 of them went down into a manhole about 450 feet away, and enough carbon monoxide got in there that carbon dioxide that they were overcome, and it took 3 men out of one family in one afternoon. So it is a very real threat. Thanks, Jim. Let's go to your question.
Yeah, what kind of information shall a contractor present for a protective system at depth greater than 20 feet?
You're going to want to make sure that the tabulated data matches up, and it should have a registered engineered stamp on it that the system is designed for that depth. Sometimes you can't get a standard system that would fit it, and then you're going to need the system to be designed by a registered professional engineer.
Okay.
So back on that tabulated data, you saw the engineer stamps. That's why I say it's important you are making sure you're properly classifying your soils to match your soil conditions, because you can see it went from, I believe on that one, it went from like 32 feet down to 18 between a type B to a type C 80. It's important that it matches up. And also, one last kicker is make sure you're referring to your local regulations on everything. Kind of as Curt mentioned, like I was in California, so we had Cal OSHA. There we already had where a competent person could be held civilly and legally liable if you put somebody in an unsafe trench. But you just want to make sure you're working off your local regulations.
Okay, one last question. What or how should small utilities monitor or work with their subcontractors doing excavations for them? Do they rely on the subcontractor's competent person?
That one gets touchy. The agency I was in, if you start directing your subcontractors, then you start becoming liable, is the way they looked at it. Again, each state is probably going to have different laws on that. I'm not going to claim to be an expert on state laws, but what we did is if it was unsafe, we would tell them they need to make it safe and point out what wasn't to Cal OSHA regulations, but they didn't want us to give direction directly to the subcontractor, because then you the fear was start taking liability over. We had the same things with even confined space entries. We wanted them to have their own equipment to make sure their equipment was calibrated and properly done, and not be using ours for the same type of reasons. If you start supplying or doing the work for them, the fear is that you would become responsible for their actions at the same time. So I guess that really comes down to a case-by-case basis and how the agency would want to approach that.
And another way that you can approach that is, as you're putting your project out for bid, make a safety plan part of that bid. Actually, kind of review what the minimum components will be on your safety plan. At how many feet above the ground must they be tied off? How is this going to be identified? How is that going to be identified? And then you ask that organization that's bidding for you that if they make it to the final process, now they have to submit their safety plan for your review. And then that gives you the ability to spot check from a distance, are they following the safety plan? You're not telling them, hey, you have to be tied off. Your safety plan says you must be tied off, so I'm going to stop the job here. That also gives you the ability to hold some accountability over them financially if they're not, because you can stop the project and make them get organized if they're acting outside of a safety scope.
Okay, excellent. All right, I see we're at the top of the hour now. So I want to thank our presenters today, Curt and Chad. I want to thank everyone that attended for joining us today. And I'll remind you that we'll have an evaluation that'll pop up here at the end. We'll want you to take a moment for that. And a reminder, the slides were part of the materials that you can download and have on your own computers if you'd like a copy of this presentation. I think that was maybe our last question. Yeah, so thanks for joining today. Be on the lookout for future RCAP webinars. I think we might have something scheduled in September, but more information will be coming out on those soon. Thank you.
Thank you, everybody.